There's so much youth wants to know, and the volume of material they must be taught is so far beyond the 3 R's and is increasing so rapidly that the educational facility, the school building itself, has got to provide for change.
We seem to be in a new era of having to find new concepts, new materials, new performance for our buildings. Flexibility of being able to regroup people, students and teachers, from the old conventional patterns in groups of from 1 to almost any number, to accommodate individual study, to accommodate audio-visual and other teaching media. Then the other flexibility to abandon this type of program and go to something that's completely unpredictable at this time. Traditionally, we were taught to build permanency. Now we're living in a more transient society, rapid redevelopment of entire areas. Permanence somehow seems, in many cases, to get in the way of what we're trying to do rather than be an asset.
These are the actual comments of architects and educators alike, and they underline the fact that today the central factor emerging in school design is flexibility. The objective: to build educational centers rather than schoolhouses, learning spaces instead of classrooms. Designers are looking beyond the traditional concepts of school construction, are searching for new ways of doing things.
So one of the things we need to try to do is create the flexibility in the building for all types of uses. Flexibility, the school administrator's term, flexibility, I think, is determined more about the creation of spaces which can be converted and used very rapidly as opposed to a major remodeling project.
One of the first new ways of creating building flexibility was California's School Construction Systems Development Program. Known as SCSD, it divided a schoolhouse into 4 basic components: structural, mechanical energy, lighting, ceiling, and interior partitions, with specifications calling for physical compatibility between each of the 4 components. The SCSD, or systems approach, did and still does offer spatial flexibility rapidly and economically. While all school districts are not able to adapt this new systems concept to their own particular building programs, it has sparked a revolution in building construction, and particularly in the manufacturing of individual building components. For example, one of the most important SCSD developments was the further refinement of the modern ceiling system.
The ceiling system appears to be a real key to this flexibility because nobody walks on it and nobody leans against it. It's in a unique position to house various services for the building in a very flexible way so that they will be very readily available. It needs to be changeable to any other point in the building. It needs to be possible to move a partition anywhere and get any kind of service in the partition. This requires a very special kind of ceiling system.
Schoolhouse ceilings, very special indeed. Years ago, they were just the tops of rooms, rigid, difficult to rearrange. But today, multifunctional ceiling systems like C60 Luminaire offer outstanding flexibility. When new methods, new equipment, or a new student populace demand spatial and ceiling rearrangement, it can be done almost immediately. Partitions, flat ceiling panels, lighted modules, supply and return air hardware, all can be easily placed to get new room shapes and sizes, the right amount of acoustical control, the right amount of light or air, exactly where it's needed. And these things are of vital importance, for to enhance education and to improve learning, today's schoolhouse must create and provide the proper environment. This ceiling system offers quality lighting that lets students see visual tasks quickly, accurately, and comfortably. Almost 70% of the light output reaches the working surface. And the interchangeability of lighted modules and flat panels provides for the right light level in virtually any schoolroom situation.
Many years ago in the red brick schoolhouse, we needed high ceilings, we needed very high windows in order to get light to the rear of the rooms, and for ventilation. Technical progress has eliminated the need for natural daylight and eliminated the need for operable sash for ventilation of the rooms.
Modern school design often creates windowless classrooms. These spaces wouldn't be possible if warm weather comfort depended on the distance a breeze could penetrate. But that's no longer a problem. Ceiling systems like this can deliver conditioned air over the entire ceiling or at specific points without drafts. They supply air and return air efficiently and quietly. And a quiet learning environment is most desirable.
The library has acoustical ceiling. It also has carpeting on the floor. And we did this because we wanted it to be possible for small groups of students to be in various sections of the library and talk to each other without disturbing the rest of the room.
Disturbances, noise, not only distractions, but problems that get in the way of learning. The C60 ceiling system can absorb 65 to 75% of all sound that strikes it, makes open planning possible and practical in areas like instructional material centers, team teaching classrooms, and libraries. In most areas of a school, noise control is a relatively simple job. But kitchens, locker rooms, swimming pools present a unique problem. But these high humidity areas can be quieted today with the development of a tough ceramic acoustical ceiling material. CeramaGuard, a ceiling that makes environmental control possible in the problem areas of a school. And where additional sound control is needed, or where standard acoustical materials can't be used, in gymnasiums, language laboratories, and music rooms, wall units can be used to soak up sound. In addition to sound control, special areas such as audiovisual centers and laboratories call for still another form of flexibility.
To have a ceiling system that has a concealed suspension system that is completely accessible would be very desirable.
When a school district wants to keep pace with new ideas, total ceiling accessibility is critical. New concepts almost always mean new wiring and piping, surfaces best placed above the ceiling plane. Labor costs make it impractical to break down and rebuild to accommodate new ideas or to repair existing facilities. A completely accessible ceiling makes such innovations possible. Products such as these have been designed to provide education with a building that can change. A building designed for flexibility, accessibility, and environmental control. But what about economy? School budgets rarely allow for more than minimum materials. Economy is a matter of two factors: initial cost and subsequent maintenance. The key factor affecting these costs is efficiency. For example, a ceiling like this delivers about 15% more light than does a recessed troffer system using the same number of lamps. Thus, you need fewer fixtures to maintain a given light level. Fewer fixtures means a lower initial cost. And because there are less tubes to replace and operate, maintenance and operating costs are lower too. Then too, since this ceiling provides UL-rated fire protection, there is no need for an intermediate fire barrier. This alone can save 30 cents per square foot in material costs and up to 6 weeks in ceiling construction time. What it all adds up to is a group of problem-solving, money-saving ceiling products that are leading the way in providing more flexible, more efficient school facilities today and tomorrow. The accessible tile system, providing ceiling-wide accessibility. CeramaGuard, acoustical ceiling material for problem areas both inside and out. And C60 Luminaire, a fully integrated ceiling in one complete assembly. These are the Armstrong ceiling systems that are giving educators the room they need when they need it, and the environmental comfort they need where they need it. They are making possible building for change.